Cheaters. Here we are again. Tonight, we're going to start with Alexi. And in particular, let me turn the volume down over here. My guy, Dream Clinic, is a little loud in my ears. Hopefully I've turned the volume down so it's not too overwhelming for you guys. Still trying to find the sweet spot to where you can hear his stuff, but then you can also still hear me. Sometimes I think actually listening to his stuff is better than me yapping, but tonight we're listening to this one, which I stumbled across when I was on a run with Doggy. Doggy's here. You want to say hello, Doggy? Doggy. Hey, Doggy. Doggy. Let's see if I can get him to say hi. Doggy. Doggy. Hey. Buddy. Okay. Let sleeping dogs lie. Oh, it's got to be let sleeping dogs lie. Let's see the doggy. Doggy. Okay. Okay. Oh, all right. So, we got the doggy. He's not happy about this. No. He's tired of Alexi's comments. Right. Okay, so we got the doggy at my feet. We got Dream Clinic. Jesus, false. Okay. We're going to try to do this episode like this. So I just want to talk about one quick thing for this episode. And then we're going to go do a couple more episodes. But this one is going to be principally about Alexi. And I wanted to just show all of you, because this is actually one of the main reasons why I created this channel, is to run into people like Alexi and Cyber. And I think I've mentioned this many times, is I don't really care. Just to be honest, I don't really care if we have 300 followers, or if we have 300 million. That doesn't matter to me. But what does matter to me is that we have at least a small quorum of Cybers and Alexis and untranslatable metaphors and so on and so forth. That, the whole getting everybody in the world to love your stuff, I don't know. I think it's hyped out, and it's also it's kind of pedestrian in my mind. And the reason why is a forward progress, I find, is often had by a small group of people that have very strong similar beliefs and a ton of excitement and energy to move that thing forward. And that's what I'm trying to do with GTT. That is the number one thing. And it's amazing because I've got 2 rock stars here. Look, there's 2 comments, but there's actually 19. Most of that is me. Well, actually, Alexi and I go back and forth on this, but it's happening. And I knew it would. And that, by the way, I don't mean this as arrogance. I mean this actually just as evidence, as I've done this a few times. And what I do is I just keep going. And people will laugh at me and make fun of me and tell me I'm dumb. I definitely should be laughed at. I laugh at myself all the time. I definitely should be made fun of. I make fun of myself all the time. And I'm super dumb. I'll be the first person to volunteer that. I find that the faster you can get your ego out of the way, the faster you can learn. And principally, I just want to learn stuff. I don't really care about that other thing. I just want to know everything. I want to know everything. I want to know all the stuff about all the stuff. Because then I can figure out how to build new stuff and move us forward. And by stuff here, I really do mean stuff, right? Like I stumble across things that inspire me, and then they kind of change the direction of my life. And I don't like follow the shiny new thing. I follow what is deeply interesting to me. So for example, when I first started learning about neural networks, it was like in 2006, maybe, something like that. I was in grad school. It was a master's class that was like go through a whole bunch of machine learning algorithms and just get a sense of the field. We learned a whole bunch of stuff, decision tree learning, support vector machines, k-nearest neighbor, genetic algorithms. Just is like a potpourri. And then we learned a little bit about neural networks. Now, again, it's a potpourri class, so you didn't really get deep into neural nets, just a little bit. And keep in mind, this is in 2007, something like that, where AI is super not cool. It's the opposite of cool. Everybody is saying, no, we're in complete AI winter. And I thought all those machine learning things were pretty neat. I liked them all. Oh, sorry, for the Bayesian people, yes, adaptive Bayesian trees were in there as well. Is it Bayesian trees or networks? Okay, maybe it's adaptive Bayesian networks. But yeah, that was in there. My bad. Sorry, Bayes people. And by the way, yes, I do believe that the foundation of a lot of the future of things is naive Bayes and causal inference. But that's for another topic. This is about finding things that deeply inspire you and looking into them irrespective of what everybody else is doing. So when I learned about all these things, one, Bayesian networks I thought were really interesting, especially naive Bayes, just because it made so much sense. It's very simple, but just made sense. It's just like, oh, of course. Now, arguably that could potentially be its downside because reasons. I mean, look, I could get into it. Maybe I'll do that some other time, but right now, I want to put a pin in it. And if you want to go down this rabbit hole and ask the question of like, why do the Bayesian network people feel left out, or what are the? I feel bad just saying this stuff because I think Bayesian stuff is actually really cool. And I think causal inference is actually super cool. And there is a very interesting binding between the two. I actually think causal inference is going to be at the forefront of the field in a very short period of time. It just makes a ton of sense. There's a book I'm reading, I forget the name of it, but it might be called Causal Inference. And its roots, I think, are essentially in naive Bayes. But then it gets like more complex from there. Anyway, all of these things I learned, just very briefly, but the one that I thought was kind of the most curious was neural networks. And the reason why I thought it was curious is that almost all the other systems that we looked at, I kind of could deeply grok them. In that, like k-means clustering, I could look at it and say, oh yeah, of course, right? It's just like this clustering, and then you have distance between neighbors, and then you pick some sort of length of the distance that is sort of the maximum you allow for a cluster, and then you just figure out the clusters. It's like, and that's cool because you can figure out this cluster is here and this cluster is here, and these guys are not clusters because they're too far apart, and blah, blah, blah. So all of this stuff made sense. Decision trees, Bayes, naive Bayes, everything. Neural networks, on the other hand, were a mystery. They were like a true mystery in the sense that they did stuff, and I kind of understood like the beginnings of the math. By the way, this is absolutely not a full neural network architecture class in grad school. They did neural networks in maybe like 2 weeks. So what can you learn in 2 weeks? By the way, somebody was really rabbit holing here, but I was talking with the Jeters, and some people were complaining the episodes are too long. And believe me, I get it. But you can clip them. But if I don't make them long, if I make them all TikToks, then nobody's learning anything. Because, okay, strong claim. I'm gonna say something really absolutist here. It's my strong conviction that to learn things that are meaningful often takes time. It takes time. It's gonna take more than 30 seconds. It's gonna take more than 3 minutes. This is why classes at the university or high school last a semester. That's why you can't learn calculus in one sitting. You can't become an expert in programming in 1 week. All these things, it takes time. And so my view, and a big reason why I'm YouTube long form, is I want to explore interesting ideas that are complex, and that's going to take time for them to breathe. We're going to talk about the same topics many times. I think that we have already. So anyway, things of substance take time to learn, and doing 2 weeks of study of neural networks in this potpourri class wasn't enough. So then what I did is I thought, wow, this is cool. I took the full neural network class, neural network architecture or something like that. And we had a full semester dedicated to that, and woo-wee, that got intense. And that was sort of the beginning of me starting to build neural networks and fall in love with recurrent neural networks, be really interested in things like sequence-to-sequence modeling, dispute the fact that the argument back in that day, if you can believe it, this isn't pretend. I'm going to say something that's going to be super audacious, or I don't know, might remind you of something Bill Gates said back in the day, which was computers will never need more than 64 kilobytes of memory, something like that, right? In 2007-ish, when I was first taking neural network architecture, the professor who just recently passed away, and I'm a bit sad about that. And by recent, I think like maybe last year. His name is, let's look him up. He's such an awesome guy. It's Howard DeMuth. Yeah, and I guess maybe this is just Martin now. And here we go. This is Howard. Yeah, so this is his obituary here. And this is the professor that taught me neural network architecture. And this is his book. Yeah. I wonder what the different... Yeah. So, absolutely loved meeting and learning from Professor DeMuth. And in that class, I just kind of went off the rails. I went probably way overboard, more than I was supposed to. And so I was building all kinds of neural networks. By the way, this is before TensorFlow and any of the other PyTorch, any of those open source machine learning frameworks, any of that. So I just built mine from scratch, wrote it all in C++, which is coincidentally something we're going to talk about a little bit in this C and C++ discussion. But at one point, I was talking with Howard about I need to make the neural network bigger, and so I've added it has 7 layers, and Howard's response was, well, Goju, or sorry, this is before Goju. Well, Justin, you're kind of doing something wrong, because neural networks should never have more than 3 layers. Now, just to be clear, I am not disrespecting Howard DeMuth, Professor DeMuth. Professor DeMuth was one of my very trusted mentors, and he is the professor that got me inspired to do machine learning. But in the era that he was trained, this is before deep learning, there was this rule that a neural network would never have more than 3 hidden layers, right? And so you can see from this picture, so this has the input, the output, and it has 2 hidden layers. The rule was that you would never need more than 3 hidden layers, and if you needed that, you're doing something wrong. True, this is the truth. I'm not making this up. And so when I was talking with Professor DeMuth, I shared that I couldn't get this thing to work, but then I added up to 7 layers, and I had maybe a couple thousand neurons, something like that. It wasn't anything like the 3 trillion hyperparameters or neurons that we have today, right? But Professor DeMuth was sort of like, whoa, there's something wrong here, because you shouldn't ever need more than 3 hidden layers. And, I'm just a lowly grad student. I was trying to be as respectful as possible, but I was kind of seeing different things. So I kind of kept it the same way and did the thing that I did. But I enjoyed this class so much that after I took it, Professor DeMuth asked me, will you just take over the class? Because he was getting to the point he wanted to retire. And this was sort of I think maybe he was starting to have a little bit of mobility things. And I think he knew that I absolutely loved the class. So we went to lunch and we talked about neural networks and the future and things. And that he offered me the job to essentially be a teaching grad student or something, where I would run the class. And I was like, yeah, well, absolutely, I love this. And that was actually the first time that I ever taught grad students. I teach grad students now all the time, but that was a little bit scary, because I was a grad student. I wasn't even a PhD student at that point. I was just a master's student. And I think there were a couple times where I had a couple PhD students while I was a master's student. Anyway, it was a good growing experience, having that awkward kind of, what do I do here? But the point of all this is the key things that I try to do in life, I try to do them more based on this idea of, I find this thing interesting. I think that it has value. And if other people don't love it, I don't know that that really matters to me. I kind of know what I want, and I want things that make me go, and I become curious and all of these things. And the moral of this story is that's what's starting to happen with GTT. So we have this quorum of people. We've got Cyber, we've got Alexi, and there's several others. And I'm super excited. I am literally beside myself with the excitement, because those incredible, unique things like neural networks, but instead humans, are now kind of flocking together. And the places that I see us going as a community is probably going to be just insane. So, along those lines, I think we have GTT now getting our core group of incredible people, and I love it, and I'm savoring this, and this is the part that makes sort of all of this mean something to me. Don't care about the number of subs, don't care about the number of views. Don't want people to just say, yeah, Goju, everything you said is perfect. I want to know more stuff. And I want to meet people that want to know more stuff and are intellectually honest and will change their mind in the face of new data and grow. And those people are really hard to find. Really hard to find. At least that's been my experience. But we're finding them and we're starting to grow. And I wanted to talk about a concrete example of that with Alexi. So Alexi, who... Are you going to show me anything about Alexi? If I do this. Okay. If I click on Alexi. Okay, here's Alexi. And he joined YouTube 15 years ago. And yeah, if you do the math, I think it's probably actually 15, not 14. Yeah, because you include the year. Anyway, so I've never met Alexi before. First time interacting with him, I think. Actually, I think that's not totally right. I think I did a video where I was talking about Jonathan Blow building video games, and I think I was looking at his code and had a very minor critique, and I think Alexi said something on why Jonathan Blow does something. So I think maybe this is his second comment. But anyway, in this VOD, I am explaining basically somewhere. Yeah. This idea of like, well, why would you not program in C++ when we kind of all know that classes are really amazing? And look at all these languages that have classes. It's in here somewhere. Somewhere? Yeah, look at all these languages that have classes. And isn't it amazing? So you should just code in C++, not C. I don't understand what the issue is. So Alexi comes back and he says this. The Linux kernel is C only. Now C plus Rust. And it's an extremely large-scale project. Rust is, in my view, the best language ever. And it doesn't have classes, which is a benefit. I programmed for many years in C#, Java, TypeScript, JavaScript, and many others. Rust is now the only one I want to use. And I know object-oriented programming is bad. There are many views. Even if you don't know everything, it doesn't mean the other side is right. So basically, Alexi is kind of openly disagreeing with me. Now, some people might read this and see this as someone that's challenging them, questioning their authority, blah, 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 bloobity blue. But when I see things like this, I think to myself, Alexi cares enough, and he's paying enough attention that he is going to put together a counter argument because he thinks that there may be more to the story than just what I'm talking about. Now, he doesn't, in this response, I think it's important to note that he doesn't say, Goju, you're wrong. He says, yeah, I know object-oriented programming is bad. And then he makes this comment of like, there's many views. And even if you don't know everything, it doesn't mean essentially the stuff that you don't know is the right stuff. And I'm trying to argue in this here is like, if you only know C, this is C, but then there's all this world out here. Don't you want to explore the rest of this world? And he's saying, yeah, maybe, but it could also be that where you are is the right spot. You know, this is the world of C++. And then, more importantly, he gets into this comment about, I know object-oriented programming is bad. Now, from my view, I'm pretty well versed in the Linux kernel. I've looked at it. I've never contributed, I don't think, directly, but I've looked at it hundreds of times, maybe. I have multiple copies in Mentor that we poke around on. All right, yeah, well, there's at least one that we've got up here. What do we have? Two. Yeah, this is the one that goes into the future. All right, that's pretty cool. If you can't read that, that says 2037. Yeah, I mean, I always knew Linus was kind of the man, but I didn't know that he could code in the future. And now I know, right? Anyway, so I've looked at the Linux kernel, and I've dabbled with Mentor and things, and yeah, it's a very impressive, very robust, large-scale piece of software, as Alexi is saying. It's probably thinking about this file because it's long-ish. Let's give it a couple. Oh, this is a .h file. Huh. Why? I'm tempted to hit the refresh button, but should we give it? Oh, look at this. It's even sort of miss. There we go. I don't know why that took so long. This is a very small file. I wonder why. Was it macros? It might be the... Yeah, I don't know. Anyway, so here's... I think our servers are just running slow. They're probably doing maintenance or something. Not expecting that Goju's going to be fiddling around on the servers at nearly midnight Pacific time, but surprise! Anyway, okay, so we got the Linux kernel, and it's great. And yep, I know that it's C only, and I know that there's the C in Rust. And it's large. I mean, it is large. Like, he is not wrong. Back to the size. 2 million lines of code. That's a lot. That's a lot of code. 11.6 thousand files. Sizable. 23,000 contributors. Woo-wee. That's some stuff. Okay. This comment inspires me, and I wanna kind of know more now. So I start talking with Alexi, and I clearly leaned in maybe a little too long. I just, I'm a tech nerd. What was this? Yeah, I think this is my first comment. I still don't know how YouTube does whatever, but I want to go through my response here. Just this first one, and then I'll scroll down, but I want to kind of get to the end. And also keep in mind that in this, I had Go. See, I have Go here listed as a language that has classes. Let's get back to this. This comes up. So I respond saying, hey, Alexi, appreciate the comment and the counter view. In truth, from my perspective, there are many possible misuses of OOP. So I want to just start off saying, yeah, you can get into a lot of bad stuff if you don't really know what you're doing with object-oriented programming. A couple of the big ones that jump to mind are, one, deeply nested inheritance hierarchies. Oh, just inheritance in general is probably something that you want to do as little as possible. That would be my guidance. I'm not saying, just to be clear, I'm not saying that you should never do inheritance. I think there's probably some cases where inheritance makes sense. But when we first did object-oriented programming, there was this hoopla about inheritance, and people would have, they'd have, sorry, the dog's kind of blocking me here, but he's more important than me being able to type correctly. Yeah, okay, buddy. Yeah, he's so happy about being the star of the show. Okay, so you'd have something like, we're going to make this about him. This class. Animal. Because he's an animal. And, hold on, I got to make this slight change here. Okay. Oh, it's all right, buddy. Okay, so you have the class animal. And then you've got your class dog. It's like public animal. And inside of this, then you've got like your class cat. I think this is maybe the canonical example that, sort of like the example that people use to explain inheritance and all of its awesomeness. And in some sense, like it kind of makes sense, right? Is that the core animal class will have these properties, like it'll have a name, and then maybe it has arms and feet, and then you can define how many. So it can give you like the base stuff, and then you don't have to do all that stuff each time because it just gets it from the base class. The problem is manifold. But one of the first things that comes out is it can start to get unwieldy real fast when you do too much inheritance. Okay, buddy, he's moving around. Now he's in this spot over here. If you do too many levels of inheritance, it can start to get real wacky in the sense that you don't even know what the base class is. Or there's so many things you think you're going to get a function, but somebody else intercepts it. And it can become, in the attempt to organize things clearly, it can actually become more unruly. Very hard to control and use correctly. So that's bad. I've seen this done quite a bit. And then it can be made significantly worse if you use virtual inheritance. When you start making things dynamically polymorphic, not statically polymorphic, dynamically polymorphic, meaning at runtime it's just like doing some stuff. Hooey, it's not the best. So in my view, this is one of the biggest, these are two of some of the biggest things that make object-oriented programming not great. And then there's others where you have languages like Java where everything has to be class. And, I think that that's super great. It's a lot of stuff, and there's a lot of stuff you can do wrong. So from that perspective, I think that I get what Alexi is saying. On the other hand, I would say that I don't know that that's actually making object-oriented programming bad as much as it's saying that if you misuse it, you can do really bad things. For example, the things that I'm describing, I don't do. But if I'm actually being fair, the fact that you can do these things, well, people are probably going to do it because they can. And if you didn't want that, then maybe you shouldn't allow them to. So anyway, I'm trying to be fair. And as I'm trying to be more and more fair, I kind of realize that I see where he's coming from, I think. Now, he responds back, and he basically is saying similar things. You can create complex software without some of its parts, like inheritance. You can use interface traits, composition instead of inherit. And these are modern languages, and they don't have classes, so on and so forth, right? And by the way, I said that Go has classes. And I was fairly certain that Rust didn't, but I was like, well, I think Go has classes. And so we keep talking, and at some point, so then I talk, after I say all the things that I think are maybe not super great, and then what's going on with Rust in the Linux kernel, then I get into like the key two things that I think make object-oriented programming really powerful. And it's these two things. It's this data encapsulation and separation of public contracts from implementation details. I think that these are two principally important ideas in object-oriented programming, and without objects, it's hard to do this in an enforceable way. And then at some point, then he's saying that Go doesn't have classes. And then I say, I would argue that Go does have classes, just not in the traditional sense. Instead, I think they have classes in the way I'm describing them above, which is basically data encapsulation and interfaces. But you're right. I think that it doesn't support classes in the traditional sense. Like, I don't think it has actual classes. Like, the word class, I think, is not there. It's like a struct with interfaces. And then there's some like other things that are actually even better, like extension of the struct outside of the scope of its definition to add new interfaces. I mean, there's, if I remember correctly, I've only dabbled in Go. I haven't written nearly enough, but Urs and others have been teaching me, and it does seem very powerful. So I'm basically saying not in the traditional sense, but in my mind, even though it doesn't use the class thing, it has this. And the beauty is that you don't have inheritance. Like, you don't have this, because this, I think, is sort of mostly dumb. And that's from doing it a lot and then realizing, whoa, this is not great. The stuff I'm doing here, it's just the coupling is unbreakable. And I started to think, yes, I mean, you don't think you want to do this for software that's iterating. And then I went on to say, I think that there's some minor cases where inheritance has value. Anyway, we go around, and then I think at some point he basically says, all this stuff. And then he's like, I think that Go doesn't have... where does he say that? Oh, here we go. Is this where he says it? Honestly, I don't like Go. I worked a few years on a security team. I contributed to this thing almost. Oh yeah, here he goes. I am almost 100% sure that Golang doesn't have classes, right? And this is, I think, a really interesting point, which gets at the heart of what we're really trying to say. Is I think he's trying to say that the things that I'm describing in object-oriented programming that are bad, and that's what makes object-oriented programming bad. Yet at the same time, the things that I'm saying that makes OOP good, he's like, I agree with that. Those things are actually really, really good. And so when I think about Go not having classes, I think, well, it does, because the stuff that I'm describing, it can do. And in my mind, that's the definition of an object. But from a purely technically precise sense, where you look for the keyword class, yeah, I don't think it has. We look it up. Does Go string? Here we go. Golang does not have the concept of classes in the same way that traditional OOP does, like Java, C++. Instead, Go uses constructs to achieve similar functionality. Okay, so concepts provide OO features. Okay, you've got the struct, right? And then you have methods. You can find methods on structs and other types in Go. A method is a function with a special receiver argument which binds the method to a specific type. This allows structs to have behavior associated with them similar to methods and classes. So here we have our person struct, and now we have this function that is called greet that takes this thing and produces this. And now we get into this stuff. We get into these interfaces. So Go interfaces define a set of method signatures. Any type that implements all the methods defined by an interface implicitly satisfies that interface. So you essentially have this interface thing, which is basically this greet function. And so then anybody that implements the greet function is meeting this greeter interface. And so then you could pass this thing that is a greeter, and then you can invoke the greet function because the greeter interface demands it right here. So yeah, that acts like a contract. It acts like an interface. And then instead of inheritance, it has composition. Yes, that's exactly, because inheritance is sort of like... So in summary, while Go does not have the class keyword or traditional inheritance, it provides structs, methods, interface support, object-oriented programming principles through composition and behavior definition. And that, my friends, is how I think of OO. And I'm sharing this because I think that once Alexi and I started talking, and I understood what he was saying, and he understood what I was saying, what we realized is we were saying the same thing. So even though he's saying that, like, OOP is bad, and I'm saying, like, if you had classes, why wouldn't you have class? Why wouldn't you take that and level up to C++? And I get it now. In fact, he's kind of changed my mind. And in this video, I was saying, correct me if I'm wrong. I might be missing something. And so he talked and I listened, and he actually changed my mind. Is that I don't know now, which I think is actually a better place to be. Okay, let me rephrase this. If I know that someone is hyper competent and can handle all the complexities of a very deep object-oriented programming language like C++, then I'm gonna recommend they code in C++. But if I have like a junior programmer that is really struggling with, let's say, something like Python, I'm gonna say code in C, don't code in C++, because C++, you're gonna probably do the wrong thing, and by the time you figure out it's the wrong thing, like by the time you get to that inheritance tree and it's the 16th level deep in your tree, you're cooked. You're so far down that rabbit hole, you might as well just throw the whole thing away, because that code is not going to be maintainable. And I wanted to share this with you because this is, in my mind, a concrete example of exactly what I'm trying to build, and I think we're trying to build at GTT. GTT may have me as its spokesperson, I'm the spiritual leader or whatever, but it's not about me. It's about us. It's about Alexi. It's about Dream Clinic. It's about cyber, untranslatable metaphor. And that's what makes all of this awesome, is just like at the university, as I tell my students, I'm going to teach you some stuff, and then I want to be able to lean on you to then teach me better, because you're going to learn things and then you're going to level me up, just like Alexi has done. And this is not false praise. This is not BS. I have changed my view. I knew that object-oriented programming could be used in a really bad way, but Alexi's point somewhere in here about he was on this project and just the rest of the team just really didn't know what they're doing. Yeah, here we go. Now, if you have a team of smart people, then it's not a problem. But that wasn't the case in my career. I wasn't that lucky. And then it reminded me, there was a time when I wasn't so lucky either. And we were coding in Java. And it went bad fast. We also were coding in C++. And I arrived after the code base already had like 1 million lines of code. Oh my goodness. It was so... They like... all the stuff that I'm saying, like, don't do, like specifically, these two things, just these two things. Do not make deeply nested inheritance hierarchies, and do not overload or overuse virtualness, virtual inheritance, virtual methods, essentially runtime, polymorphism. Is that what it is? Dynamic polymorphism? Yeah, no. It's because I think subtype polymorphism is templates, and I think that's pretty good. Hold on, let's just get our facts check real quick. By the way, I'm gonna have to end this shortly so I don't run over the time. But subtype, yeah. What I always get this backwards. A core concept or interface can be used to refer to object different types. What's the example? Okay, this is. Okay, yeah, so subtype, what's the other? There's another one that's generic code. What is that one? Yeah, because there's like these two. Okay, yeah, maybe it's this. Subtype polymorphism and inclusion polymorphism. And it sounds like subtype polymorphism is basically inheritance. Subtype polymorphism relies on inheritance. That kind of makes sense, because you have the base class and then you have a subclass that's from that. So it's a subtype polymorphism. I kind of call that, the way that I think about it, I'm probably using wrong terms, but I call this generally runtime or dynamic polymorphism versus compile time or static polymorphism. And by the compile time and static polymorphism is templates. Because you resolve all the stuff at compile time, and then at runtime, everybody knows the types. It's still polymorphism, at least in my mind, because it's like it becomes these different types, but it's not done at runtime as subtype polymorphism is. But I'm probably not using the right names, so parametric polymorphism. That's the one, right? Yes. Okay, cool. All right. So yeah, now we've figured it all out-ish. So you have subtype polymorphism. You have subtype polymorphism, and you have parametric polymorphism. And this is basically inheritance. And this is basically templates or generic programming. Cool. And I think Don't do that. Do this. And this is why I like C++ so much. As I think I've mentioned many times, I love writing templates. So easy. I mean, I know it's hard, but in my mind, when you get beyond the syntax, it's like beautiful music. Like, seriously. It's like being able to express extremely deep, powerful thoughts that will potentially turn into thousands of lines of code, and you do it in 10 lines. I mean, it feels like you have superpowers. And it's also so easy to manage. It's so easy to maintain because you only have 10 lines of code or something like that. Whereas the subtype polymorphism stuff, this is a maintenance nightmare, guys. This is all over the place. It's classes are here, classes are there. Nobody even knows what this class is, where is the top of the subtype polymorphism? Like, if the tree starts at the bottom, what's the top? Are you at the top, or is there something potentially above you? I mean, there are all kinds of strangeness. So the overarching point of all of this is this discussion, in my mind, is really, it's kind of like the whole point of GTT. And I just wanted to thank all of you for watching and commenting. Not just Alexi, but Cyber and our gutsy David and Empty Code and Bear and so on and so forth. Like, that's the whole point, is to do this because as much as you may think that the point is about me leveling all of you up, really, it's about us leveling each other up. And selfishly, Alexi has leveled me up here. Like, my view has actually changed. And it's kind of funny now, because I think when I'm given this, I even said, like, I've thought about this and, like, hey, prove me that I'm wrong in the comments, but I've thought about this and, like, it's awesome. I was wrong. It's great, right? It's wonderful. And this is also part of the reason why I try to use weak claims, even on things where I think that, yeah, look at this. This is avoid knowing the things that you don't know. And what's interesting is I was trying to make the point that this is really like, why would you not do this? Because this could potentially level you up, so on and so forth. And in fact, and like in some sense, I thought I knew, and Alexi demonstrated to me I didn't actually know. And I love that. I seriously love it. Nailed it, Alexi. You nailed it. So everybody, that's all for the time being. I've got a ton more to do with VODs this weekend. This is the first of hopefully many. So keep growing.